Good day everyone. Today we will be sharing you the working steps on how to answer the SPM question 2011-2012. Now let's have a look at the question. Figure 5 shows a 0.4 kg block being pushed against a rough vertical wall by a force F at an angle 45 degrees with respect to the horizontal. The block remains stationary. So our first question is, sketch a free body diagram of all forces acting on the block. The second question is, if the coefficient of static friction mu s is equals to 0.20, what is the magnitude of F? Now let's begin with our first question. Sketch a free body diagram of all the forces acting on the block. So what is free body diagram actually? Free body diagram is a diagrammatic, graphic, symbolic representation of an object, complete or partial part of another object, in which all the acting forces are shown with their relative magnitude and direction by directed arrows. Now let's have a look on the free body diagram. On the x component, we can see there is normal reaction acting on the object. As we all know, normal reaction will only occur when the object is in contact with the surface. Now next, on the vertical component, we can see there is weight acting on the bottom of the object. As we all know, W is equals to mg, mass, multiplied by gravitational acceleration. On the other hand, we can see there is frictional force acting on the top part of the object. In this diagram, the object is moving downwards, and as we all know, frictional force will act opposite to the motion of the object. Hence, in this situation, when the object moves downwards, the frictional force will be acting upwards. Alright then, there is force acting and for the arrow which represents our force, we have to draw it back on the positive x-axis, and the angle in between it will be 45 degrees. Figure 5 shows a 0.4 kg block being pushed against a rough vertical wall by a force F at an angle 45 degrees with respect to the horizontal. The block remains stationary. So, the question is, if the coefficient of static friction mu s is equals to 0.20, what is the magnitude of F? So now, on the horizontal component, the total force on the horizontal component is equals to 0. It is because it is stated in the question that the object is stationary. It means it is not moving. Hence, the total force on the vertical and horizontal component will be 0. So now, let's see at the first equation. Our normal reaction subtracted by our Fx will equals to 0. Hence our N is equal to F cos 45. So this will be our first equation. And our second equation includes our total vertical force. Our total vertical force is 0 Newton. So based on the free body diagram, the forces that acts on the vertical component is our frictional force, our weight, and also our Fy, F sine 45. So when we add all this, it will be 0. As I mentioned before, the object is in stationary motion. Okay, so after that, we have to substitute our first equation, which is N equals to F cos 45, into our second equation. So once we substitute, we will end up with the answer F equals to 4.63 Newton. Our final answer must have the unit and magnitude.